So in the last video on concentration, we looked at percent concentration, and that broke down into several different options. And we looked at parts per million, and each one has its value, each one has its role. But when we talk about concentration in chemistry, most of the time that we say concentration, what we mean is molar concentration, or the other word is molarity. So we're going to focus on that one. And we said that time it was going to be its own video. You're watching it. So this is, again, unless I otherwise say, if I say concentration, I mean molar concentration. Now I sometimes refer to it as molarity, which comes back in a minute. So if you're wondering on what that word looks like, I'll tell you that, show you that in a second. It is the number of moles of solute, so not the mass of solute, not the milligrams of solute, but the number of moles of solute in 1 liter. It's not 100 milliliters, but in 1 liter. Moles in 1 liter, which means its unit is going to be moles over liters, or moles per liter. Now, as I said, that is sometimes called molarity, and I tend to flip back and forth between that. I'm probably more comfortable with the word molarity than I am with molar concentration. I also am more comfortable with the symbol M, but if I look at your textbook, it uses this version of it more often. You saw that version, you saw that formula kind of in the previous video, but if you go back and look carefully, it's a lowercase c. So capital C is for capital concentration, I guess, which for chemists means molarity. We can have a triangle, kind of like what we had for something else as well, where number of moles on top, volume on the bottom, and concentration or molar concentration in the other corner. Well, we're going to use that a little bit. Now we know how to use that. What is the concentration? So that's the C. Well, if I get rid of C, I'm looking at N on top, volume on the bottom, not a bad looking V, but not a good one either, and I take the numbers that I have and I use them. So 1.36 divided by 3.8 gives me 0.36 moles per liter. Too easy. But if I tweak that a little bit, so what is the concentration? So that's the same. If 650 milliliters, oh, wait a second, I can do concentration is number of moles over volume, but this requires, the volume requires liters. So first I have to convert liters into milliliters. And I know that 1 liter is 1,000 milliliters. So convert the milliliters into liters. Now, important, this is what you have to do, but you don't have to show it. Okay, so if you can do it in your head, okay, 650 milliliters, move the decimal place 3 times. If you can do that in your head, or even if you have to use your calculator, you don't have to show it. What you do have to do is come up with 0.65 liters. That's important. Now I can use my formula, or number of moles divided by volume. Now I can do those things, and I get 0.54 moles per liter. Oh, wait, this is different, because if I look at the formula that I have, concentration is number of moles over volume. I've got a volume, but I don't have a number of moles. So what do? What I do not do is say, I'll use that number. I know something about mass and a given chemical formula. I know the relationship between the mass, the molar mass, and the number of moles. Look, I'm looking for number of moles here. I need number of moles. I can calculate number of moles. And I'm going to do that by mass divided by molar mass. 6.4 grams given in the question. Molar mass I get from periodic table and the chemical formula. That means 0.075 moles. That's the N that I've been looking for. So now I put that in for N, 0.075 moles divided by 0.35 liters, and I get 0.215 moles per liter. If the question is what mass is required, okay, I can actually do some similar things, but I'm going to need both triangles again. Now notice, the question says what mass. So I should already be thinking that mass is number of moles times molar mass. But I don't have moles. Well, I can calculate moles from concentration and volume. So here's a concentration, molar concentration, here's a volume, and clear up some space. So I first calculate numbers of moles that I need. Concentration, molar concentration times volume in liters. gives me that many moles. Okay, now I know number of moles, I know molar mass because I've got a chemical formula, and I'll calculate mass. So I can do lots of things with this formula and start combining things that I've done before. And I get end up with a mass of 15.16 grams. This question, what is the new concentration if 35 milliliters of 1.6 mole per liter solution is diluted? Now, one of the things that's kind of important to realize is the number of moles of solute before is the number of moles of solute after. I added water, but I didn't change the amount of solute. So I can calculate the number of moles of solute before to get that. And that means that the number of moles of solute stay the same. So when I figure that out, I get this. We can do that in a slightly different way. I could say that the concentration before and the concentration times the volume before, which gives me a number of moles, is equal to the concentration after and the volume after. And then I can actually solve this without going through two steps. I could put in my, where did I have it? I've got 35 milliliters, 0.035 times 1.6, and that equals, don't know, so I'm going to leave that as C2, and 0.72. And I can just solve for the second molarity, second concentration, second molar concentration. Okay? That was a bit of a whirlwind, I know, but I know you've also done a lot of these calculations. You've done a lot of stuff. We'll take it up in class. We will have some example questions, another worksheet, that kind of thing. We'll take some time with it, but it's mostly just rearranging formulas and making sure that you're putting things in where the correct units go. Okay, that's really all there is to it. Talk to you in class. See you.